Right. Thank you all, first of all, for joining. My name is Viren, and in the next few minutes, I am going to talk about durable executions and the importance of having kind of your application um, with having executions which are kind of durable in nature. We'll talk about what does it mean to have durable executions, what kind of frameworks does it support, and what does it mean for an application to have their application flows to be durable. All right, so let's first talk about applications and their states before we go talk about durable executions. When you think about applications, applications that we write today, these are essentially state machines. We embed and encode states of application and businesses inside our application. And if you think about it, there are two kinds of states that application has. There is a business process state, and there is an application state. And there is a kind of very clear difference between the two, where you have an application state, which essentially is the state of your application code. So think about, when you write a function that, has kind of bunch of statements with, conditions, parallel fork joins, and, calling other functions and so forth. Somebody is maintaining the state of execution, right? Like, I have executed statement 1, 2, and, why I'm at 3, it's in progress, or maybe it failed and exception has been thrown and so forth. If you think about, let's say, a traditional order management system, this would essentially represent, how you are writing the code to, let's say, process an order. Like, you are essentially doing some sort of validation of the order to check if you have the item in the inventory or not, if all the, item ID or the SKU matches in the order or not, and things like that. Then you are maybe, calculating the tax, checking more things, and so forth, right? You are waiting for maybe the fulfillment to complete. When you think about the business state of this order, they don't necessarily represent the business state, right? Business state becomes more like the order has been received, it has been processed, and it has been delivered. So, it kind of represents two different things. Now, when you think about application flows, just like, when we think about business state, the application flows also requires durability, because, for one thing, we all know this, that application flows are complex. They are ever changing. And when we think about failures, oftentimes when we are writing code, we all know that, like, we a lot of time writes a lot of defensive code, a lot of protections against failures, because, failures are norm, right? We all would love to be in a place where there are no failures. And when we think about failures are not only about, application code failure, right? Like, we live in a world where, like, application is not a complete monolithic, where, everything is inside the application, like including your database. You have database, you have network, you have external services, you have some sort of messaging systems. And when you think about it, any of those things can fail. If nothing else, your DNS might fail, that is where one of the dependent services is running. And then, everything might be fine. You just can't call it because your DNS is not working. So, failures can happen. Failures do happen, not maybe all the time, but, a percentage of time. And if you are running a sufficiently large enough workloads, they are happening all the time. And we all know other part is that, like, when we want to implement heavy path scenarios, assuming that everything goes well, those are relatively easy. The reason being that, like, we can literally focus on implementing the core part of the business logic, rather than thinking about what do I do when, step 2 fails, and, how do I recover from that, and so forth. And this is where, like, bulk of the time goes in application development lifecycle, where, we are thinking about those failures, recovering from those failures. When we move on to different projects, and, this application is essentially handed over to people who are responsible for, maintaining them. So, we add a bunch of dashboards and, other kind of process flows and UI, so that, they can actually manage this. The other thing why your application flows essentially requires durability is that, if you think about it, oftentimes what happens is it's distributed across many functions and systems. Now, these functions could be part of the same application. where like, you have function one in one module and second module and so forth, everything running on a single process or a JVM, or a container. Or it could also be distributed across multiple systems where like, they are calling into a different system, they are dependent on another systems and so forth. And this applies to even the monolithic environment. Like, we think that like, just because everything is in a single environment, my flows can be completely kind of non-durable. But reality is that even then, unless until like, you can rerun the entire flow over and over again and again without without having any side effects, that is typically much harder to do that. And in some sense, if you think about it, right, the classic fallacies of distributed computing applies even to monolithic environment, because things will go wrong, and when they go wrong, if you don't have the right defense in place, it's going to corrupt the application state. Now, so this is the reason why application flows need to be durable, right? Let's think about, as I said, like a very hypothetical, simplistic example of an order processing system. Typically, what you would do is, you will start by validating the order, whether it is correct or not, as I said, right? And for the brevity, I have kind of omitted some of the complexities here, so it can fit it in a single screen, and it's kind of palatable when we are looking at it. And then we are doing some text calculation, invoice generation, and so forth. Now, there are interesting things here, right? Things like, for example, let's say my text calculation relies on a database where I have some sort of mapping between zip code and the text rates, um, and this database might be, let's say, a legacy database that needs to be upgraded, but we haven't had time to do that. So, once in a while that query fails, or maybe that query takes much longer than expected, and the entire that call to kind of execute the query hangs in for instead of few milliseconds, few seconds or so forth. So it becomes a bit of a problem there. Second is, we are using an external system, right? One of the cloud providers to send out an SMS, and we are on a tier which enforces strict rate limits. So sometimes during the holiday seasons, or when there is a high volume and we try to send out SMS to do order confirmation to users at mass, we end up getting rate limits, 429 errors, and we have to retry, and of course it will succeed after doing a retry. A very real world example here is I was kind of playing with GPT-4 recently, and I will keep rerunning the same query multiple times. Every now and then I'll get a rate limit error saying that no, your request, because I'm still on a free tier, it's like, is rate limited, and wait after 4 seconds, and now your query will go through. And I wait for 4 seconds, I try again, it works. Now imagine this becoming kind of real life scenario day to day in a production environment. Then comes a very tricky situation. This is an order management system, right? And the order processing also requires fulfilling the actual order, which means the warehouse is actually shipping the order. User is tracking the order, and once it is delivered, you get some sort of notification from your delivery partner, maybe FedEx, UPS, or USPS, or whatever it might be, that hey, user has confirmed the delivery. And once it is confirmed, you want to basically complete the process. Sometimes your fulfillment only stops at like sending the shipment. In that case, you just want to kind of send a tracking ID saying that, no, hey, we have shipped your order, here's a tracking ID, and you can track, and if something goes wrong, talk to the delivery partner. And of course, things can go wrong, right? In that case, like, you also want to kind of handle the errors and maybe terminate the flow and send out an email to the user saying that, hey, sorry, item is out of stock. Or maybe, the pricing has changed, so therefore we can't process further until you resubmit the order, so we don't overcharge you and things like that. So, as you can see, right, like even these 5 lines of code, if I want to productionize these things, you got to think about a lot of other things that are not written here, but are implicit in terms of, assumption that my code will actually do it when it's running in production. So yeah, as I said, right, like text calculation is flaky, it fails sometimes. So I have to make sure that, like, if it fails, just retry, because, I can calculate text 100 times, it has no side effects. Same thing when sending order kind of gets rate limited, I should retry after some time, and, I know it will go through. So yeah, this is why, you need the state across the different statements, so that, like, when the calculation of the text has failed, my order processing is not complete yet. I don't want to kind of throw an exception and send an error message to user saying that no, hey, my database is down. That doesn't make sense, right? I should retry. Similarly, when I can't send an SMS, I should retry so that no, it will succeed further. But somebody has to kind of keep track of where am I. Um, so the way I like to kind of talk about this is that when you think about durability in today's world, right, it's kind of table stakes. It's like saying that no, my database that I choose should not lose data on failures and it should provide durability. Of course it should, right? And that of course your application should. Which means that if I invoke the process order function, it must complete. The execution must be guaranteed that it will complete if I start. This means that I don't have orphan records in my database. I don't have duplicate transactions. I don't have to do a cleanup job. I don't have to go and we all know this, right? Handle dead letter queues and so forth. So if we say that durability is table stakes, what else do you need? Is it good enough to just have an application flow that is durable, or choose a framework that lets me have durable executions? So let's think about it. So we know, we identify two brittle points in my application, right? One is, sometimes tax calculation fails. Do we know why does it fail? We hypothesize that hey, the database is a problem, but is that the problem? Or maybe there's a problem with the container then on which it is running, or maybe it's running on a bare metal and that machine has some problem, or maybe there's a networking issue. It's running on a different network altogether, and maybe there is a connectivity problem. How do we know why this is failing? Of course, we can check logs and do all of these things, but imagine this is running, hundreds of millions of calls every day. How am I aggregating this data and figuring this thing out? Second thing is that, we talked about rate limits, right? So what am I going to do? Am I going to just put a for loop here and say, send an order on error, slip or retry? But that can happen multiple times. And what if my SLA changes now and says that hey, we are on a higher tier, we will never get rate limited. If at all, we'll be charged extra as opposed to getting rate limited. So in that case, I want to probably do a self rate limit rather than paying extra money, because the SMS can go 4 seconds later. That's not the end of the world. So the meta point here is that when things are running in production, you want to be able to debug these things in production, right? I want to be ideally able to kind of see this visually, the code that I have written. And I'm taking a kind of different example here that is slightly more complex, right? Imagine my order flow is, or process order function is not as simple as 5 linear calls. It has, for example, let's say parallel executions. Maybe it's a batch order processing, and I am doing a large amount of orders in parallel, maybe tens of thousands of parallel processed forks. Maybe it's a bulk order shipment thing. How am I tracking those things and making sure that it's part of a single order? Or maybe I have kind of loops, or maybe I have kind of child workflows that are doing other things inside the flow. How do I kind of monitor them? And of course, we have not talked about yet in terms of how am I going to wait until 2 or 3 days or even a week before my order fulfillment is ready, right? Until that call comes, what's happening to my function call here? Is it waiting there? How do I add a wait statement here? That becomes a tricky situation, right? And if my function returns here, then what happens to the next one? How do I kind of build these things, right? So as I said, right, just having durable execution is not enough. You also need to be able to debug these things in production. And then ideally debug it fast enough without having to go through 20 different machines checking the logs, or investing into a totally different log aggregation and monitoring system that can give me logs. But I will see that, oh, this database query failed. Which application execution was this part of? I have to now log all the relevant information there. And then you start worrying about leaking PII information or the sensitive information. It's at scale, everything starts to get a lot more complex than we would like it to be. And then of course there's always this time, right, where we got to answer this question as to how does everything work? Can you write up a document on your application logic so that we can improve this further later on? Or hey, my boss wants to know what's our current implementation, so I can go and get the budget approved, so that we can do the V2 version of it, or we can put it in your promo packet, or any of those things, right? um, so the other thing is, my code should be self-documenting. If I were to spend time writing documentation for my code, the moment it goes to production, the documentation is going to be completely out of sync with my code. We all know this. So self-documentation of the code is extremely critical. The other piece is, you don't want to kind of put versions as switch conditions, right? If then else, if V1 then do this, if V2 then do this. What if I want to do a combination of V1 and V2? Am I going to do like what, V1.2? And what if I want to kind of test out a different version of the function with a canary testing? Then I need to have another function, process order master, and then based on some input criteria, it calls V1 or it calls V2. What happens when I introduce V3? Then I have to go and change the code again. What if I don't want to remove this whole thing? I don't want any more experiments. I just want to call V2 or V1 always. All of these things, the moment you start putting things into the code, that becomes difficult, right? And versioning with function name, we all know this always equals to technical debt, because V2 just keeps on evolving until it's V20 and it's still called V2. So again, beyond durability, I also want to be able to kind of version my code and make sure that I can actually run this, test it out in production, right? Not in dev environment. Some of the things like testing the implications of moving to a different order flow. It's not about whether it works or not, whether it's about what kind of business impact it has in terms of the revenue, in terms of the cost and everything. That can only be tested in production. And therefore, things like canary or A/B testing exists. So durable exec code frameworks, right? Many of them kind of helps you do things like, add durability to the code, or provide some level of logging so that you can see what's going on. And these are the frameworks that lets you kind of bring execution durability. They also guarantee execution, so that once you call a function or a process, it guarantees that it will complete most of the time at least once semantics, and with some kind of effort also exactly once guarantees. And in the end, how they implement this is essentially through orchestration as a pattern, right? If you think about the code, what is code, right? It's orchestrating across different statements, and this frameworks essentially implement the exact same pattern here, except that it is going slightly down deeper into the code base, where it is going at the code level orchestration. And in the end, what does it do to me, right? This is all great, but I am a developer. My job is to kind of implement this feature. What does it mean for me, right? Where it helps me, where it comes down to the bottom line, is it lets me focus on the business implementation where it matters, right? Business is not paying so that I can handle retries correctly, right? Yes, the business needs that, but that does not move the business forward. So with this kind of frameworks, essentially I can focus on the real meat of the situation, right? Where there is an impact and there is a value addition. But just like everything else in life, right? Not every framework is equal. There are things that you want to consider when choosing the right platform. The first thing is, can I debug and monitor my application flow, and not at isolated level, right? Once or twice. I should be able to do that at scale. If I am running hundreds of millions or even billions of flows every day in production environment, can I pick the ones which have failed in few seconds and find what's going on there, right? If you think about it, the enemy typically is not that we can't find and fix the bugs. The enemy typically is the time, that we don't have time, and oftentimes, you are running against the clock. Imagine you are an e-commerce service running this process order thing, right? It's the holiday season, maybe it's Christmas Eve, and you got to make sure that all the orders are processed, or it's right before the Black Friday sale, and there are error rates are going up. How do I know which flows are failing and what's going on and everything, right? I should be able to do that very fast, very quickly, so that I can fix it, because finding a bug is one thing, fixing is second thing. And second is, again, we talked about this, right? The versioning aspect is another thing. And also, in today's world, polyglot has become kind of a nature. Can I write some part of the code in let's say Python, where I'm dealing with machine learning and AI, some parts in Java or C Sharp, where it is more business facing, or maybe in Rust, for example, right? Where it's doing some CPU intensive, low latency stuff. And it answers all the questions that we talked about earlier, right? Like in terms of self documentation of the flow, can I build really complex flows where I have thousands of parallel folks, if not tens of thousands of, right? Can I run millions of concurrent executions, not serial, like literally running them in parallel? I have 20 billion order processes that are currently in progress, and they are probably all going to complete before, let's say, 26th of December. Can I do all these things? Can I monitor and analyze the patterns of failures? Do I know which is the service that fails most often? Where are my brittleness that exist in my application, right? What are my latencies? How many calls a particular function is being made? So I know where to optimize and things like. And then more importantly, just very common patterns, right, that are like table stakes. Like, can I implement caching? Like for example, text calculation is a perfect example of caching. Given a zip code and an amount, I can cache the result for maybe a day, right? Laws are not going to change within a day to change the text calculation. Similarly, can I implement things like circuit breaker patterns and other patterns? So when you're thinking about the framework or a platform, these are the important questions that I want to kind of get answers to before I go and pick one that comes to my mind. And there are also anti-patterns, right? Just like there are anti-patterns for everything else, there is one for here also, right? Which is, and some of these are based on the experiences that I have had, we all had, and so this is a collection of those things. By no means this is the complete list, but these are like some of the major pain points, right? One, of course, is you don't want to kind of implement versioning the code. We talked about this, and this is often very overlooked aspect of systems is versioning. Our codes are never static code, right? Our codes are always evolving. They are like living, breathing. Every few months there is a change. Hopefully sooner than that, but it's safe to say that once in a year, your application logic your changes, and when it changes, you want to be able to kind of isolate that from the underlying implementation. And other piece that I think recently has gotten also a bit of traction is not exposing everything as an HTTP endpoint or a microservice. Not everything needs an HTTP endpoint, because the moment you want to put an HTTP endpoint or HTTPS endpoint, you need to think about API gateways, load balancer, but DNSs, the whole bunch of infrastructure that is sometimes completely unnecessary. And what about things like, for example, handling the load, right? Back pressure handling with HTTP services is much harder to implement compared to things like worker-based approach. The other anti-pattern is to kind of have a task call one another directly. And the moment you do that, what you're doing is you are essentially encoding your entire application logic inside your task, making them stateful in nature, much harder to change, much harder to reuse, and things like that. And the last two are more about how do you handle some of the parameters around resiliency. If you have rate limits that you want to enforce, you want to handle failures, and the moment you start writing code for those things, then you are losing the advantage of having this kind of frameworks. So ideally, you want to kind of keep them completely separate. Your code should be completely focused on implementing the business logic with an assumption that everything is just working fine. There are no failures, there are no rate limits, and those are handled separately. In terms of when that really happens, how do you handle that? Maybe you retry them, maybe you fail the entire flow, maybe you kind of enforce rate limits on your side, so you never make more than 20 calls per second for order processing, because that system can't really handle more than that, and there's no point pushing more volume. And of course, then system should be able to handle the back pressure also. What happens when there are 50 calls and you only want to push 20? The remaining 30 should just get queued up in a FIFO fashion somewhere. So these are some of the anti-patterns, right? And as I said, this is not the exhaustive list. But the key point here is you want to keep the business logic very simple with stateless idempotent code. Assumption that everything kind of always works, and then let the platform handle all the edge cases for you. And this is where Conductor essentially comes, right? Conductor is that platform that helps you build resilient, durable, distributed applications, and it goes beyond just as I said, durable execution framework, because to me, that is table stakes, right? That has to have. If I am building a database today, if you are building a new database today, durability is kind of table stake. It has to be there, right? Like, you don't think about, I'm going to build a new relational database and I'm going to make durability my key selling point. That's not going to work, right? My key selling point has to be probably, oh, it can do high performance, maybe it can do high cardinality joins, maybe it can do time series and document and relational and graph all in one. It's a multi-model, right? So that's where Conductor focuses on. Conductor focuses on building applications that are completely heterogeneous, right? Monoliths, microservices, humans, serverless. Essentially, you build your application the way you want to build it, the way your businesses, your underlying application infrastructure demands you to build it, with your own language and framework, right? If you are bought into, let's say, Python Django, you should be able to use Python and Django, or maybe you want to use Spring Boot, you should be able to use Spring Boot. And the Conductor server essentially takes care of all the concerns that we talked about, ensuring your applications are kind of implements all the patterns of durable code execution. At the core, essentially, Conductor builds on the event-driven orchestration as a pattern and adds things that does not exist otherwise. But it is well suited for things like monolith, serverless, and of course microservices. And it was designed and built in the cloud, but runs pretty nicely in data centers as well. So let's take a look at, if I were to kind of now implement the exact same thing in Conductor, how will I do this? It's the same piece of code. There's no change. The only change here is that, you are essentially creating a Conductor workflow, giving it a name, and giving it a version, so you can change it later on, and essentially adding all the tasks. But if you notice here, there are no try catch blocks. There is no if this then that. Assumption is that everything works, and then for every task, if things fail, I can configure the task to retry, add rate limits, and whole bunch of things, and it automatically captures all the metrics, everything for me. It knows exactly where things are. And this is a very simplistic example, right? But this can get really complex with a very large number of forks, for example, or extremely complex business processes, which are even difficult to visualize even in a 40-inch monitor. So how do I get started? So Conductor is open source. It's Apache 2.0 licensed project. There are a lot of contributors across multiple industries and companies. So, any new feature, bug fixes, suggestions, definitely welcome. You can find it more on the GitHub link here, or just go to conductor-oss.org and you can find it. One other thing you can do is you can go to play.orkes.io, give it a spin, which does not require you to install or do anything. And yeah, if you like the project, if you want to support it, definitely give us a star. That definitely helps us spread the awareness. But more than that, talk to your colleagues. Let us know if we can help you. And yeah, with that, I'll end this here. Happy to take any questions or any follow-ups.
Thank you, Viren. Questions are coming. So the first question is, with the open source being maintained by Orkes now, do you have a roadmap for the open source? Can you share how you plan on prioritizing features, most requested features you're considering integrating?
Absolutely. So our roadmap is in the open source. So if you go to the roadmap on Conductor OSS, you should be able to find the link to the GitHub project that talks about the roadmap. We have identified the roadmap for kind of at least up to the Q1. And the main focus is twofold, right? One is ensuring that the open source is in a very good state in terms of, the topmost priority is to make sure that the bugs, the security fixes are kind of patched as soon as possible in the open source. Second is in terms of focusing on some of the kind of the features that we have been building in Orkes Enterprise. Our plan is to kind of push some of those features back to open source as well. So, we will continue doing that. And in terms of the prioritization, I think the focus is always like, things that are the least common denominator, right? Like things that is going to be broadly applicable to multiple, users and companies and things like that. Awesome. I think there's a second question. What means for conductor?
Yeah, second question. I'm gonna read it for everyone. What means of conductor have for regression testing of workflows and rules?
If you think about something like conductor, right? A great advantage of conductor is that server has the entire execution logs for your workflows. I will share the link after this. But control also lets you kind of run things like replays of the workflows, right? So you can take the entire execution, replay them with mock data. So very similar approach to how you would do mock testing or regression testing. This is also approach that we do it internally when we have a very large scale kind of changes or things that we think are very structural to the core conductor. Is we take the existing executions, we replay them against the new version, and then we validate the outputs across both of them, that if the workflow had failed in the previous version, in the new version also it should have failed with the same error code. If it succeeded, it should have succeeded, and the number of tasks that it completed should be exactly same, the output should be same, and so forth, right? That gives us super good confidence in terms of that my process is going to continue working as it is without changes. So this is one of the most critical advantage of having a platform like Conductor, that you can actually replay everything from Conductor. The second piece is anomaly detection. So, one advantage of having another point is something like Conductor is that it can push all the logs into a metric system. So, you can integrate this with Datadog or open source Prometheus, New Relic, and leverage their systems to do anomaly detection, right? Conductor in the end is not in the business of doing things like anomaly detection and things like that. But this information can definitely be pushed, and it does integrate very well with those systems to kind of handle those cases.
I have another questions on my own, Viren. As you said during your session that durability is a must-have, and you use the expression table stakes. So we clearly understand the importance. What about if I already have my application in production today, and I would like to make sure that it becomes durable, and how Conductor can help me? Is it possible without rewriting everything?
Yeah, absolutely. 100%. And the reason is this: Conductor is extremely lightweight when it comes to their SDKs and frameworks. So one philosophy that Conductor follows is that we don't want to enforce a custom SDK onto you or a way of doing things. And the reason is this, right? That we all kind of work in a constrained environment, right? One way or another. Like what kind of programming language we can use, what kind of frameworks within that programming language we have to use, what version of those things. And we probably already have some SDKs already integrated, right? Adding more and more SDK integrations and deeper integrations inside code also means that tomorrow when I have to refactor those things, it's going to be equally challenging. Every new step every new type of SDK you add in your system adds equally, just adds one more kind of extra, condition in terms of testing and migration. So, the way Conductor was designed was, you can very easily kind of use Conductor without necessarily, rewriting your application. Like in my previous example, for example, I have the Python functions. I can just annotate them with Conductor workers, do the same thing with Java or C#, and starts to move parts and parts of the application flow. So take, for example, if I have, let's go back to the example here, right? So this is my Python code that is kind of not running on Conductor. And I know that my calculate text is a bit of a problem, right? I want to kind of move this to Conductor. What I can do is I can essentially just move that one piece to Conductor, and then remainder kind of continues to operate as it is. So, strangler pattern is not something new. It has been kind of very well documented and used across multiple industries to do this kind of things. And Conductor supports it very well. In fact, as a matter of fact, when we built Conductor, This was one of the requirement that we will do this slow migration, right, using strangler pattern to conductor from the existing systems. Short answer is yes. Yeah.
So in the meantime, another question came out. A lot of good points have been made around design, timeouts, error handling, etc.
Mm-hmm.
How does Conductor compare with general orchestrators that provide this, like temporal.io, etc.?
Yeah, so I think at the core, Conductor is very general purpose orchestrator like Temporal, right? Like it supports durable, or it is meant to kind of handle things like durable code execution. Where Conductor kind of differentiates itself is we started thinking, right? Like, okay, durable execution is there. Is that enough? Like if I were to run the large case distributed systems in a production environment, it's like the same principle applies, right? That I talked about in database. When we are choosing a database to use, let's say, we all have gone through this once or more times in our kind of careers, right? Is should I choose Oracle or MySQL or MariaDB or Postgres or Spanner or whatever, right? We are not thinking about do they support durable execution? Of course they support, right? That's why it exists. We're starting thinking about does it support more things? Like in today's world, like today, given all the discussions about LLMs, right? We are thinking, oh, does it support vector storage? So I don't have to now invest in another vector database. Does it support multimodal? Because multimodal has become a thing, and people are using databases which are not just purely relational. So the conductor essentially goes beyond the saying that to run an application in production environment, you need a lot more than those things. And how do we kind of support them? So that's where conductor kind of differentiates and improves. So I would say conductor is more like a V2 of durable execution frameworks, right? It started originally as V1 that was not even open source, to be honest. And this is essentially the battle hardened V2 version of code orchestrators.